All right, here we go. Starting with chapter 8, and we are starting with 8.4, it looks like on the calendar. So we are doing 8.4, 8.1, and 8.2, and then you guys will be having your next exam, I believe. Okay. All right, so 8.4, parametric equations. All right, so let's first start off with what parametric equations are. Parametric equations are a set of equations used to represent a single equation or curve, okay, by using a third variable called a parameter. Okay, so I'll give you an example. So you might have these two equations, x equals 24 square root 2t, and y equals negative 16 t squared plus 24 square root 2t. Okay, and so these two equations here would be the parametric equations for the single curve or single equation y equals negative x squared over 72 plus x. Okay, and we could easily check this. Okay, so here, if I take the first equation, right? So if I take the first equation and solve for t, okay, so I'll take this equation, x equals 24 square root 2 t. Okay, so solving for t, I would need to divide both sides by 24 square root 2. And that will give me t, right? Okay, so then now what I can do, since I have this value for t now, I could sub t value into the second equation, the one with y. Okay, so I get, here, let me bring this down a little. There's that second equation, that one with y. So I'm going to replace the t there with x over square root 24 square root 2. X over 24 square root 2. Okay, with this. All right, so y equals negative 16, and I'm going to plug in x over 24 square root 2 squared plus 24 square root 2 times t. So I plug this back in again, 24 square root 2. Okay, and when I simplify all this, you'll see I better get what's inside here. Okay, so let's take a look. All right, so this gives me negative 16. going to square everything. And I have a calculator with me, so you work it out. But I'll do it by hand. 24 times 24 times 2. Okay. And over here, these guys will actually cancel out. So I'll just have x. And then over here, let's see, 2 can cancel out with 16. So I get -8. And this here will cancel here, leaving me with 3. So I get negative x squared over 3 times 24, which is 72, plus x. Okay, and I believe that's what we said it equals. Yep, negative x squared over 72 plus x. Okay, so we used these two here. We used these two parametric equations to represent this single one here with the x and the y. So it almost seems like more work to have two equations representing one, right? Okay, so let's take a look at the difference. Okay, so the single equation versus the parametric. The single equation, you have y equals negative x squared over 72 plus x, right? This is a parabola. It's negative, so it opens down. Okay, so it looks something like this. If we were to graph this, right, it looks something like this. Okay. So when you're given just this single equation, this is x and y axes, right? So here we have that and we have that. And if we use this to describe the motion of some projectile, right? Then here, when it's just in terms of x and y, then we can tell two things. We know the horizontal distance that it travels, this projectile, right? Like, think of it as maybe, I don't know, a football or something. Okay, so we know the horizontal distance it travels, which would be the x, right? And we also know the vertical distance, how high it goes. Okay. So that's what we can tell with a single equation, right? Horizontal distance and vertical distance. When we look at parametric equations, okay, so let's take a look at the two that represented that single one right above here. Okay, so the parametric equations for the single one were these. X equals 24 square root 2t, and y equals negative 16 t squared plus 24 square root 2t, right? So what happens now is, yes, this will still represent the same curve, right? And we'll be able to tell the horizontal distance, and we'll be able to tell the vertical distance. But now we will be able to know those particular distances at a particular time t. So that's the difference. So here with the parametric, we can tell the horizontal distance. We can tell the vertical distance. And we can tell these two things for a given time t. And that's what's kind of nice. Okay. All right. So when we are graphing, we can still do our table. So let's take a look at this one. Sketch the curve given by the parametric equations. Okay, so suppose that we have these two. Suppose that I have x equals t, and I have y equals negative 3/4 t. Okay, so there are a couple of ways to do this. One way is to just make a table. But in this case now, you would be choosing a t values. Okay, so like 0, 1, 2, I don't know, 4. Doesn't matter. You choose whatever values you want. And then you're going to be plugging them into the two parametric equations and solving for x and also solving for y. So let's fill in the table for the x. Okay, so when t is 0, we get 0. When t is 1, we get 1. When t is 2, remember I'm plugging into this equation to find the x. Okay, so when t is 2, I get 2. And when t is 4, x is 4. Okay, I'm going to fill in the table for the y values using this equation over here, plugging in the t values, these guys up here. Okay, so when t is 0, I get 0. When t is 1, I get negative 3/4. When t is 2, I get negative 3/2. And when t is 4, I get negative 3. Okay? And what you end up doing when you graph is you only graph the x and y. Okay? So let's go ahead and see what this looks like. And that t is telling us sort of, we're getting direction now from our graph. So let's go ahead and see what this looks like. All right. All right, so 0, 0. So again, I'm only doing the x and the y. So we have a point at 0, 0. We have a point at 1, negative 3/4. We have one at 2, negative 1.5. And we have one at 4, negative 3. Okay, so we see we're getting this linear graph that goes this direction over time. Okay. Now, another way you could have done this was eliminate the parameter and see what the single equation is, and then just graph that. Okay. Let's take a look at another one. Let's sketch x equals 1/2 t, y equals 3 over t minus 4. Okay. Again, if we do the table with t, x, and y, t, x, y, and we pick some values. So maybe we choose 0, 1, 2, 3, 4, 5, and 6. Maybe try some negatives in there, but let's see what we get with these. Okay. So when x is 0, we get that. When t is 0, we get 0 for x. When t is 1, we get 1/2. When t is 2, we get 1. When t is 3, we get 3/2. When t is 4, we get 2. When t is 5, we get 5/2. And when t is 6, we get 3. Okay. All right, let's find the y values. So when t is 0, we get -3/4. When t is 1, we get -3 in the denominator, so we get -1. When t is 2, we get -3/2. When t is 3, we get -3. When t is 4, interesting, when t is 4, we get 0 in the denominator. So right here, it's undefined, right? 0 in the denominator is undefined. Okay. All right, let's keep going. So when t is 5, we get 3. And when t is 6, we get 3/2. All right, so let's take a look and see what we get for the graph. Okay. All right, so our first point, 0, -3/4. Next point, 1/2, -1. Next point, 1, -1.5. Next point, 1.5, -3. Next point, 2, undefined. Okay, 2, undefined. So we're not going to have a point there. Next point, 2.5, 3. Interesting change. And then 3, we get 1.5. Okay, so here it might be like, oh, what's going on here? I can't really tell. Okay, so again, this is one way to do the graph. We did this first graph like that, and it was very easy. We were able to make the table, and it was clearly a linear graph. This one, it's a little harder to see. So let's take a look and see what happens if we eliminate the parameter and we rewrite it to see what the single equation is. All right, so let's get those equations again. So alternate method for graphing. Obtain the single equation. So we're going to solve for t and then replace it in the other equation. So I'll use that first equation. X equals 1/2 t and solve for t. So when I do that, t equals 2x, right? Okay. And then I'm going to go ahead and take that value of t and substitute. Y equals 3 over t minus 4. Okay, so when I do that, this is a single equation that I obtained. y equals 3 over 2x minus 4. Okay, and here now it's easy to see that, oh, okay, so the graph here is supposed to be the graph of this rational function here where we have a vertical asymptote, right? Vertical asymptote at x equals 2, okay, which is why we were getting this undefined over here. So let me go ahead and throw that in there. So we were getting undefined here, okay, and then here we have a horizontal asymptote. Since it's the degree is smaller on top, we have one at y equals 0, okay. Scroll, there we go. All right, so we have asymptote here. And now it's easy to see that, oh, this is what the graph is supposed to be looking like. Okay. So it just depends. If you're struggling to get that graph, and we saw how these points were obtained over time. So we saw that, okay, this is what was happening with the graph. Actually, it was going the other way. So it was going downward. So here, let me just verify, 0, -3/4, and then as time got higher, 1/2, -1. So we were going like this. This is how the thing, whatever is trying to be modeled, was behaving. And then same thing with up here. That's the only thing with doing this with eliminating the parameter and getting the single equation. You'll get the graph, but you won't get the direction over time. Okay. And depending on, I'm not sure what the what WebAssign will be asking for. Okay. All right. All right. So eliminating the parameter. So let's kind of focus on that. Because that is one way to do those graphs, eliminating the parameter. If you are struggling to figure out the behavior of the graph from just making a table. So eliminating the parameter. So you saw there that we would take one of the equations and solve for t. Okay. And then you would substitute it into the other equation. Okay, so let's take a look. All right, so given parametric equations, x equals t squared and y equals t minus 2, eliminate the parameter. Okay, so first thing, you need to solve for t, and then second thing, you substitute it into the other. Okay, so I'm going to go ahead and it doesn't matter when you're just eliminating, when you're graphing, it's probably easiest to solve for t in the x equation and plug it into the y equation. But when you're asked to eliminate the parameter, it doesn't matter if your single equation is written in terms of x or y. So when you have to eliminate the parameter, I would just kind of look at the two choices, right? And decide which one is easier to solve for t. Okay, so where I would get a single value. And so in this case, to me, that would be solving for t in the second one, the bottom one, the one with y. Okay, so let's solve for t. So using this one, I'm going to solve for t. Very easy to do. Just add 2 to both sides. Okay, and so now I have a t value. So now I can go ahead and substitute. Sub into the first one. Okay, so instead of writing t, I'm going to write y plus 2. So x equals y plus 2 quantity squared. And there you go. You have single equation with no more parameter t. And that's all they're asking you to do, is to rewrite it in terms of a single equation where the t has been eliminated. Okay? No need to graph this. All right, let's take a look at another one. Eliminate the parameter. X equals 1 over square root t plus 1. So that's one equation. And this one, y equals t over t plus 1. Okay, so when we are trying to decide which one to use to solve for t, now, which one do you think looks easier to solve for t? First one or the second one? So some people might choose the second one, the one with y. They might choose that one because they look at the radical in the first one and they think, oh, I don't feel like dealing with a radical. But the second one, the one with y, might be a little bit trickier just because you have 2 t's and you're trying to solve for t. So because you have the 2 t's, that might actually make that second equation a little trickier. All right, so let's solve for t. And I'm going to use this one. Okay, so x equals 1 over square root t plus 1. All right, so first I'm going to go ahead and eliminate the square root. So I'm going to go ahead and square both sides. When I square both sides, I get x squared. And over here, I get 1 over t plus 1. Okay. Squaring both sides gets rid of that square root. Okay. And I'm going to go ahead and multiply both sides by t plus 1 to get rid of it. All right. And now I'm going to divide both sides by x squared. Okay. And now solving for t, subtract 1 on both sides. All right, so now I have a t value. So now I am going to substitute it in for this t in the second equation. Okay, so I'm going to replace the t's in this equation over here. Replace all those t's with this 1 over x squared minus 1. Okay, so y equals, I have a t up there in the numerator, so instead of writing t, I'm going to write 1 over x squared minus 1. I have another t in the denominator, so I'm going to write that again, 1 over x squared minus 1. And then it has a plus 1. Okay? And so then simplifying this, I can combine the negative 1 and 1 in the denominator. Okay? And so I get 1 over x squared minus 1 for the numerator. And then over here, I get 1 over x squared. Okay? And here, just like before, I could get rid of my fractions by multiplying everything by x squared. So that's what I'm going to do. I'm going to get rid of x squared. So I'm going to multiply everything by x squared to cancel the x squares. But that means multiplying even this -1 by x squared. Everything needs to get multiplied. So then they cancel. They cancel. And I am left with, trying to get my black ink back. Here we go. And I am left with 1 minus x squared over 1, or just 1 minus x squared. Okay, and that would be your answer. Okay, so your answer would be y equals 1 minus x squared. That would be your single equation eliminating the parameter. Okay, let me just show you one more with some trig equations in it. All right, so let's take a look at this. Let's eliminate the parameter. Okay, so when you have trig equations, it just kind of depends. So let me show you this one. 3 cosine theta, y equals 4 sine theta. Okay, so these are a little bit different. Okay, so here we're going to make use of our trigonometric Pythagorean identities. The sine squared plus cosine squared equals 1. Okay, so we're going to make use of that. So if we're going to make use of sine squared plus cosine squared equals 1, then I need to get sine squared and cosine squared, right? Okay, so let's go ahead and square both sides of both equations. So both sides of both equations. Okay, so if I do that, I get x squared equals 9 cosine squared, right? Because I'm squaring both sides. I got to do it with both equations. Okay, so I'll do the y equation as well. So I will get y squared equals 16 sine squared theta. Okay, all right. So again, I am trying to take advantage of the trig identity, the Pythagorean trig identity, sine squared plus cosine squared equals 1. So let's get the cosine squared and the sine squared by itself on one side. Okay, so we are going to isolate the trig function in both. Okay, so looking at that first equation, x squared equals 9 cosine squared theta. So if I want to get the cosine squared by itself, I need to divide both sides by 9. Very good. We got the cosine squared by itself. And now I need to do the same thing with sine squared. Let's get the sine squared by itself. So let's divide both sides by 16. Okay. And now what I can do is I can add both sides. So here, okay, so here, it's like here's my equal sign, right? And on the right-hand side, I get that cosine squared plus sine squared, right? Here, I'll write it out. Cosine squared plus sine squared. There's my 1. That's going to be 1. Okay. And on the left side, I'm going to add those two together. So I'm going to get x squared over 9 plus y squared over 16, right? But sine squared plus cosine squared is just 1. So I don't even need this here. I can just say 1. Okay. And there's your equation. There's your equation with the parameter theta eliminated. Okay. So this would be your final answer. And in the next chapters coming up, you'll see what the graph of this looks like. This here is going to be an ellipse. If you remember your conic sections from some previous math classes, that is an ellipse. All right, so that is it. That concludes 8.4. We're starting with 8.4 before we start with 8.1 and 2. Okay, so we only have 2 more sections and we'll be done with chapter 8. All right, you guys make sure you message me if you have any questions.